both these things that we're doing today have to do with the prime factorization that we did yesterday. So if you have any questions, you can ask them now. No? All right. So the greatest common factor. It's a set of numbers, the largest whole number, which divides exactly into each term. So you'll be given a few numbers and be told to find the greatest common factor of them. So on your sheet, you can see an example. What would be the greatest common factor of 8, 16, and 20?
4.
Talk about it with your group and see if you can figure it out. So the greatest common factor is the largest number that divides into all those numbers. What is it?
4.
4. It's pretty simple with small numbers, right? So, yes, Joe. Okay. The next question. We're going to have to find the greatest common factor of 48 and 72. In this example, they've given you the prime factorization of those numbers. The prime factorization of 48 is all of that, and of 72 is all of that. So we're going to show you a simple trick to find the greatest common factor of things. So to find the greatest common factor, nope, you don't just guess, because the numbers you're going to get are going to get larger and larger, right?
I think.
Okay, so all you have to do to find the greatest common factor, you look at the prime factorization, and you're going to pick out all the things that they have in common. So, there's a 2, and a 2, and you just keep going. 2, 2, 2, 2. There's a 2 here, but we don't have a 2 in this one, so we stop. So we have 3 2s. Write them down. 2 times 2 times 2. And then you do the same thing for the next number that you have. So what's the next number? 3. How many 3s do we have? We only have 1 in each. 1 here and 1 here. There's an extra 1 in 72, but since we don't have 1 in 48, we just ignore it. Multiply this by 3. All the numbers you just collected down here on the bottom, if you multiply them together, that'll give you your greatest common factor. 24. So 24 is the greatest common factor of 48 and 72. Your examples, you're going to get more and more numbers, so it's going to ask you the greatest common factor among 24, 48, and 70. Or they're going to ask you larger and larger numbers. You're not going to be able to just do it in your head. It's going to be way too hard. So if you do your prime factorization from yesterday and use this trick, it'll be really quick.
How did you get those numbers?
How do we get those numbers? So, which numbers? These ones down here or these ones up here?
The ones up there.
The ones up here? These numbers are from doing prime factorization from yesterday. Remember our trees?
Oh.
So your trees or your charts, that's where these top numbers came from. Make sense? Any other questions?
Skip over.
The plug-in is shot on this thing. So it's kind of, if I fiddle with it, it'll change color. On your own, we have to find the greatest common factor between 90 and 225. I'll do the prime factorization of 90 on the board. You do 225 on your own. So, I'm going to do it with your tree. Remember, once you have a prime number, circle it.
What about 250?
You're going to do 225 on your own. I'm doing 90. 225 shouldn't be too crazy hard. When you have 225, put your hand up. The prime factorization of it.
Right?
Give it, 225. You got it. Keep working on 225. Good. Joe's going to do it using a tree. It's hard, eh? Because your shadow goes in front of it. Yeah. How many people did trees? Put your hand up.
I did a big little tree.
How many people did cables? Put your hand up. Okay. Perfect. Thank you, Joe. And we'll circle in prime numbers. Did everybody get this? So for 225, you should have 3 times 3 times 5 times 5. Is that what you got? Yeah, I cheated. Okay, now we have to find the greatest common factor. How do we do that? Scott, how do we do it? How did you get those numbers? Right, so what he did is he looked at both sets, and he took all the things that were in common. So he looked. There's a 2 at 90. There's no 2 at 225, though. There's a 3, so we can get rid of that 2. There's a 3 here. There's a 3 here. There's a 3 here. 3 here. 5 and 5. What do you do with this extra 5 on the 225? Get rid of it, right? It doesn't have a partner matching up. If it doesn't match up, just get rid of it. So, the greatest common factor is equal to all the things we underlined. 3 times 3 times 5. And what's that equal to? 45. Seems simple. Slow down a bit. Okay. I'll give you a second to catch up. Any questions about greatest common factor? We're about to move on. To make this easier on yourself, when you're writing out your prime factorization like this, your product of your prime factors, try to do them all in order. And try to do them from smallest to greatest. So the way I went 2, then 3, then 5, it'll keep everything in a nice long order for you. It is. Don't worry. If it's not on, though, I'm going to look down.
Wait, why is the microphone on again?
So every day, it's for the blog. Every day we videotape this lesson. All you see is the screen, and you hear everything we say, all class. And then it goes on this website here. So if you're ever lost, camera's in the board. If you're ever lost on something when you're doing your homework, you can go back and see what we did in class. Okay, lowest common multiple. So factors, we were looking for things that go into the biggest ones. Multiples, we're getting larger and trying to find what's in common. So the lowest common multiple, the LCM, of a set of numbers is the lowest number that each number evenly divides into. That's a lot of words, right? A lot of math words. Okay, let's make it simple. If I gave you the numbers 6 and 8 and asked you for the lowest common multiple, you need to get larger. That's the lowest common factor. So the lowest common factor is what goes into the numbers I gave you. When you're doing common multiples, you have to write out the multiples of the numbers. So you go up. Those are all the multiples of 6, and it keeps going, right? And then here's a whole bunch for 8. And then you want to find the smallest one they have in common. What is it? 24. Right here. That's the smallest number that both of those original numbers, 6 and 8, multiply into. What's another common multiple of them? 48. So you first fill in the blank here. Common multiples of 6 and 8 are 24, 48. The lowest common multiple, though, which is what you're constantly going to have to look for, is 24. Now, again, we're going to see larger numbers and greater sets, so you need to know a trick for it. The trick, again, comes from the prime factors. You can see a trend, right? So to determine the lowest common multiple of two numbers, you write out their prime factors. We have them down here. So we're going to do an example with 10, 12, and 14. And what you're going to do is, instead of taking, before we found all the ones in common, now we're going to use all of them. And we're going to use the smallest number. So, the lowest common multiple, we're going to look at the number 10. And we have a 2. And then we're going to check and see where else is a 2. So there's a 2 here and here. So we can cross out all these 2s. And you take the lowest amount. So the lowest number of times we saw the number 2 was in 10, right? So we write down just 1, 2. If we had seen 2 2s in every set, we would write down 2 twice. What's the next greatest number we see? 3. What's the lowest number of times we see 3 once it's used? Just once. Next number. 5. And multiply by 5. And what's the next one? 7. That's the last one. Multiply all those numbers together, and what do you get? 210?
Yep.
Do 210 divided by 12. What is it?
17.5.
Right. So that's something wrong, right? The issue is, when we saw our 2 here, I told you guys take the smallest number, you take the biggest number. So we saw 2 2s, so you actually do the square. I got it backwards, so even I'm confusing it. So, when you're doing lowest common multiples, we'll erase this quick. Yep, we'll review right now, because that was my mistake. Yep, ready? You look at each number. We start with 2. And then you look through each one, and where do you see the most number of 2s? In 12. And how many are there? 2. So you have to use both. So it's highest, yeah. And then you can cross out all your 2's. And you go through each number and you do that. So the actual answer should be
420.
420. Really? Come on.
That is
Yeah.
so groovy.
So does that make sense? For greatest common factor, we were taking the smallest number that we saw, and lowest common multiple, we're taking the greatest times we saw it. Joe?
So you always go with like the number which has the most, and so you go with like 12. So that's 2.
Yeah, absolutely. So you take the one with the greatest number. So because it was 12 had 2 2's, we used 2 2's. And then the next prime number that we found was 3. And the most number of times we saw 3 was where? It was in the 12. And we only saw it once. So we write down once. Any more question about lowest common multiple? Yes. The highest amount you see for the lowest common multiple. Yeah, it's confusing, right? It's kind of reversed. Any more? And then it's just worst case after that, right? You don't have anything after that? Perfect. You guys are welcome to work on your assignment.